In this, we will understand about purchase inventory model with the shortages. In this model, an item on order will be received instantaneously, means there is no lead time required for receiving the material after placement of the order, and it is consumed at a constant rate, means the demand will be constant throughout the year. The purchase price per unit is same irrespective of order size. These are some of the assumptions considered in this model. If there is no stock at the time of receiving a request for the item, means shop floor is asking for a item's requirement and there is no stock for it, then it is assumed that it will be satisfied at a later date with a penalty. Means immediately it will not be replenished. You allow some time and to produce the material at a later stage, wherein you may incur some penalty that is allowed in this, that is called as back ordering. So based on that, this model is represented graphically as below: quantity, and your x-axis the time. So this is our x-axis and this is our y-axis. Now, you start with this maximum inventory. Let us say inventory maximum I suffix m, and this we know it is 0. So you start with the maximum inventory, started consuming that material in the shop floor like this, and finally it reaches 0 stock. Then immediately you are not replenishing it like the previous model. You allow some time for it to be out of stock. This is the time where there is no stock, and then from here you produce the material. Means this particular point is, this is the shortage quantity. Means I will say maximum shortage, s suffix m. That means this full quantity, whatever we thought like this from here. Let me redo it. So from here, maximum inventory quantity till this, that will be your quantity what you are planning to order. That is your Q. That means it is very clear that our Q is equal to maximum inventory plus maximum shortage. Maximum inventory plus maximum shortage. And when during the consumption, that time period is considered to be T1, and this time period for which the shortage will exist, that is considered to be T2. That means the total cycle time, small t, will be your T1 plus T2. So this is the model, and some of the notations which we are going to use in this model are D equal to annual demand in units, CO is the ordering cost per order, CS is the shortage cost per unit per annum, CC is your inventory carrying cost per unit per annum, Q is the ordered quantity, and Q star will be the optimal order quantity or economic order quantity. I suffix m is the maximum inventory, what we saw, and I suffix m star will be the optimal maximum inventory, the best maximum inventory or ideal maximum inventory. Then SM is the maximum shortage or maximum stock out quantity, and SM suffix star will be your optimal maximum shortage or optimal maximum stock out quantity. T1 will be the period of positive stock where the inventory will be there, which is getting consumed, and T1 star will be the optimal period of positive stock, and T2 is period of shortage. T2 star is your optimal period of shortage. Then T is the total cycle time. We already saw T is T1 plus T2, and the optimal cycle time will be your T star. So now going back to this, we may notice that here the IM can be expressed as D times T1, the annual demand times T1. That will be the maximum inventory. That means we can rewrite T1 as IM divided by T. Similarly, our maximum shortage quantity will be D times T2, which means our T2 will be SM divided by D. Means this is our period of positive stock, and this is your period of shortage. Similarly, now Q is D times the total cycle time, which means our T can be written as Q divided by D. So that is your total cycle time. So based on these understanding, we can now compute total cost, which is TC, and that is nothing but, or I can say this is annual total cost. That is nothing but annual ordering cost plus annual carrying cost plus annual shortage cost. So we can now rewrite this TC as ordering cost. Ordering cost can be calculated as number of orders in a year multiplied by ordering cost per annum. Number of orders per year will be D divided by Q, and ordering cost per order will be CO. Carrying cost. For calculating carrying cost, we need to calculate first average inventory. We may notice average inventory is here, means it is the area of this triangle. Area of this triangle is, I'm talking about this triangle. Area of this triangle is half into B into H. So it is half times T1 into I suffix M plus, here another triangle is there, but there is no stock, means this, there is no stock. So we will say half times T2 into 0, whole thing divided by the total time, that is T1 plus T2. T1 plus T2, we know it is T, so we will replace it. Means now for calculating total carrying cost, we will write this, means half times IM into T1 divided by 2, and then this term is becoming 0, divided by T1 plus T2 will be nothing but T. So this is nothing but T plus shortage cost. Shortage cost is again average shortage multiplied by the shortage cost. I need to multiply this carrying cost per year per unit multiplied by CC plus shortage cost. This is again average shortage we have to calculate. Let us come here. This is the shortage period. So if I have to calculate the area of this triangle, the base is T2, height is SM. So half into B into H, in the sense half into T2 into SM divided by the total time period, which is T1 plus T2, or simply T. So that is your average shortage. Now here, if I have to calculate the total shortage cost, it is average shortage multiplied by the shortage cost per unit per annum. So it is SM times T2 divided by 2 times T, the whole thing multiplied by C suffix S. Now, that means our TC, total cost, will be D times Q inverse CO plus IM. We know, we already saw here, IM is SM, Q is IM plus SM. Now I will rewrite IM as Q minus SM. That will be our IM. So I will be replacing IM with this Q minus SM. Q minus S suffix M. And what is T1? T1 is IM divided by D. So T1 is IM divided by D, which is again Q minus SM divided by D. So we will be substituting that here instead of T1. T1 instead of T1, I will substitute Q minus SM divided by D. Q minus SM divided by D. Here we have that carrying cost 2 times T. What is T? T is Q by D. So T is Q 2 times Q by D. In this D and this D gets cancelled. So you will have only that 2Q. Similarly, the next one, SM will be written as it is SM. T2, what is T2? We may notice T2 is SM divided by D. So SM divided by D. Then we have CS in the numerator. In the denominator, we have 2 times T. T is nothing but Q divided by D. Again, this D and this D gets cancelled. So now this TC can be rewritten as D Q inverse CO plus Q minus SM the whole square times CC divided by 2 times Q plus SM square CS divided by 2Q. Now, if I have to find optimal SM value, that is optimal maximum shortage. So I will say that as SM star, we will partially differentiate TC, that is total cost, with respect to SM. So it is now and then and equate it to 0, means the first derivative is equated to 0, which means partial derivative of total cost divided with respect to SM. Now, first term do not have SM involved in it, so it will become 0. Second term, this CC divided by 2Q, this is considered to be constant because it doesn't involve any SM in it. Now, if you differentiate this Q minus SM the whole square, it becomes 2 times Q minus SM, and then you need to differentiate the inside term. If I differentiate Q, it is 0, minus SM, if I differentiate it with respect to SM, it is -1. Plus, here again, CS divided by 2Q is considered as a constant. Now, if I differentiate Sm square, it is 2 times Sm. Now, this is equated to 0. So, we can cancel this 2 and this 2, this 2 and this 2. And then I can take this entire thing is actually having a negative sign. I can take it to the other side, which means CSSM divided by Q is equal to Q minus SM times CC divided by Q. Both sides we can cancel Q. And the right hand side can be rewritten as Q times CC minus SM times CC. Now I can bring this negative SMCC to the right side. It will become CSSM plus CCSM is equal to Q times CC. So in the left hand side now, SM can be taken outside. We will have SM times CS plus CC is equal to Q times CC, which means our SM, which is now optimal because already we differentiated and found out, SM star will be Q times CC divided by CS plus CC. So that will become your optimal maximum shortage for this particular model. Now, again, we are supposed to find out what will be the optimal order quantity or economic order quantity. Let us rewrite the total cost, which we already did here. This one, dq inverse CO plus q minus sm the square cc divided by 2q plus sm square cs. This q I will take it to the numerator in both the cases. Reason is, in this case I can take, reason is I can differentiate it with respect to q for that reason. So means I will rewrite this tc as d times q inverse CO plus, here I will retain q which is there in the denominator only, so that I can apply u by v method for differentiating. Cc divided by 2 times q plus sm square cs divided by 2, and then there is a q in the denominator which I will take it to the numerator. It will become q inverse. Now partially differentiating tc with respect to q means partial derivative of tc with respect to q will be, first term, it is dco. If I differentiate q inverse, it is minus q to the power of minus 2 here, plus cc by 2. I will keep it as constant. Consider the rest of the term, that is q minus sm square divided by q as u by v. So if I differentiate, it is u, that is q. Differentiating q minus sm the whole square, you get 2 times q minus sm. And then you will go inside and differentiate this, which you will get 1 minus 0. It is 1 only, so you can ignore it. Minus v, that is q minus sm the square. Now differentiating denominator, which is q, you get 1. The whole thing divided by v square. V square here it is q square. Plus the last term. We may notice this sm square cs by 2. All these are considered as constant. Sm square cs by 2. And if I differentiate q inverse, I get minus q to the power of minus 2. And now this is equated, first derivative is equated to 0. So what do we get? Let us take this term to the right side and even this term to the right side. Means we will have cc by 2 Q square. And then we may notice this Q minus Sm is common in these two. I can take that also outside. Q minus Sm. Open a bracket now. What is left now? 2Q is there inside. Here you will have Q minus Sm because one Q minus Sm you took outside. The other one is still there. Now taking this term to the right side, you will have positive DCO divided by Q square because this Q power minus 2, if I take it to denominator, it will become positive. Similarly, here also, it will become plus Sm square Cs divided by Q square. Everywhere Q square is common in both the sides, we can cancel. Means you are multiplying left and right with Q square so that this Q square gets cancelled. Now, let us rewrite this. We have Cc Q minus Sm. This will be 2Q minus Q. It is Q. Minus or minus Sm, it becomes plus Sm is equal to, just a minute. Yeah. So here we also have this 2. Here this 2 is there. That 2 I can take it to the right side. It will go to the numerator. So you get 2DCO plus, here what it is, here again you have this 2 here. Yeah, this 2 I missed to write it here. 2 is here. So here if I take 2, I mean when I cross multiply this 2, here you will get 2, here you won't get 2 because the 2 will get cancelled with this 2. So plus Sm square Cs. That will be the result. Now, this is like A plus B into A minus B. So we can rewrite it as Cc Q square minus Sm square is equal to 2DCO plus Sm square Cs. Let us expand it in the left hand side. It becomes Cc Q square minus Cc Sm square is equal to 2DCO plus Sm square Cs. Now we need to find out Q in terms of the rest of the things. So I will take this to the right side. Means you will have now Cc Q square is equal to 2DCO plus Sm square Cs plus Sm square Cc. Means this term I am taking to the right side, it becomes positive. So this is nothing but Cc Q square is equal to 2DCO plus Sm square is common. So we can write it as Cs plus Cc. Now divide both sides by Cc. We get Q square is equal to 2DCO divided by Cc plus Sm square Cs plus Cc divided by Cc. That means our Sm square means already we evaluated Sm somewhere here. Sorry, where is that? Yeah, here it is. So we will use that here. So Q square will be 2 times DCO divided by CC plus SM square will be written from here as QCC by CS plus CC. Q, that means Q square CC square divided by CS plus CC the whole square, and here you have CS plus CC, denominator you have CC. So this one term goes, so you have only CS plus CC. Here one term goes, you have CC. To the left side, you will have Q square minus Q square CC divided by CS plus CC is equal to 2D CO by CC, which means Q square can be taken common in the left hand side. You will have 1 minus of CC divided by CS plus CC will be equal to 2D CO by CC. That means our Q square, let us take LCM as CS plus CC. Here you will have CS plus CC minus CC is equal to 2D CO by CC. So this and this gets cancelled. You will have Q square is equal to, means this will go to the numerator, this will come to the denominator. So you will have 2DCO by CC times CS plus CC divided by CS. This is Q square, which means Q is square root of 2DCO by CC times CS plus CC by CS. Since this we obtained by differentiating partially total cost with respect to Q, we call this as optimal order quantity or economic order quantity Q star. So based on the derivations, whatever we did, the optimal values for these models are as follows. EOQ, just now we did the derivation 2DCO by CC into CS plus CC divided by CS, whole thing under square root. This initially we did optimal maximum stock out. It is nothing but Q star CC divided by CS plus CC. And we know optimal maximum inventory will be the difference between these two. And T star is optimal cycle time, which is Q star divided by T. T1 star is optimal period of positive stock, which is IM star divided by D. And T2 star is optimal period of shortage, which is SM star divided by D. And optimal number of orders per year is D divided by Q star. So based on these optimal values, let us do one numerical problem. The question says the demand of a bought out item in a store is 12,000 units per year. The carrying cost is rupees 2 per unit per year, and the ordering cost is rupees 600 per order. The shortage cost is rupees 10 per unit per year. Find the economic order quantity, number of orders per year, maximum inventory, maximum shortage, cycle time, period of positive stock, period of shortage. So first of all, we need to identify the model. Demand, annual demand is given as 12,000. So we will say capital D is 12,000. Then carrying cost per unit per annum is given. So CC is given as rupees 2. Then ordering cost per order is given. So CO is given as rupees 600. Shortage cost is given, and That is the reason this is a purchase model, because they gave us ordering cost and shortage is also given. Shortage cost is also given. So it is a purchase model with shortages. So CS is given as rupees 10 per unit per annum. We need to find out EOQ first. First question, which is our Q star, and it is square root of 2DCO divided by CC times, we already have that formula, CS plus CC divided by CS. CS plus CC divided by CS. So let us substitute the values. It is 2 times D, which is 12,000, times CO, which is 600, divided by CC, which is 2. And then here CS, which is 10, plus CC, which is 2, divided by CS, which is 10. Now, if we evaluate all these things, means if we calculate all this, two times 12,000 into CO divided by 2 and 12 by 10, we get 2939.39 units. Approximately, we can round it off to 2940 units. Okay, next one, number of orders per year. Number of orders per annum will be D divided by Q star. Annual demand is 12,000 and Q star we calculated as 2939.39. That will be how much? Let us calculate. $12,000 divided by 2939.39, we get approximately 4 orders. That is your second question. Third question is maximum inventory. Before calculating maximum inventory, we'll calculate maximum shortage. Maximum shortage, which is S suffix M, the star. Let us see what is the formula we derived at. Q star CC divided by Q star CC divided by CS plus CC. Q star we calculated here 2939.39, 2939.39 multiplied by CC. CC is 2 divided by CS plus CC. CS is 10, CC is 2. So 10 plus 2. Let us calculate this. 2939.39 into 2 divided by 12. We get 489.89, which is rounded off to 490 units. That is your maximum shortage. Now let us go for the third question, which is maximum inventory. Since we have Q star and SM, this can be calculated easily. I suffix M star, which we know it is Q star minus of SM star. Q star, let us take the rounded off quantity, which is 2940. 2940 minus 490. We get 2450 units. That is your maximum inventory. So till fourth question we did. Then cycle time, T or T star. Cycle time, which is T star, is It is reciprocal of this, means Q star divided by D, Q star divided by D. Q star is 29. Let me write the decimal value. Finally, we'll round it off. 2939.39. Demand, annual demand is 12,000, isn't it? Yes, 12,000. Let us calculate this. 2939.39 divided by 12,000. We get 0.2449 in terms of year, and we will round it off to days. Multiplying by 365, we get 89.4 days approximately. That is your cycle time. The next one is period of positive stock. Period of positive stock. Which is T1, the star, and that we know it should be IM star by D. Let us check once again. Yeah, it is IM star by D. IM star we calculated as 2450 divided by D. What is that? 2450 divided by 12,000. We get 0.2042 year. Convert that into days by multiplying it with 365. We get 74.5 days. So then the seventh one, period of shortage, which is T2 star. We know T1 star plus T2 star is nothing but T star. That means we can write this as T star minus T1 star, which is 89.4 minus 74.5, which is 89.4 minus 74.5. We get 14.9 days. So these are the things asked in the question. 7 questions. We solved it. In case if you find the contents of this video to be useful to you, I request you to please like it, share it with your friends, and also subscribe to my channel. Thank you.